Hello guys, how are you all? Okay, so today we will see a very interesting pattern. Today we will discuss a pattern, okay, which looks like Burj Khalifa. Okay, so I think you have all heard about what is Burj Khalifa. So Burj Khalifa is the tallest building, and we will develop a Python code where we will try to develop such a pattern, okay, which will look like Burj Khalifa. Okay, so for your reference I can show you, okay, how Burj Khalifa look like. So if you see the building of this Burj Khalifa, it is like we are having what, a staircase. Okay, so from the left hand side if you see, so if you are moving in the upward direction, then we are getting like staircase. Okay, so we are getting the pattern like staircase. Okay, so we are getting in this manner. Again, the building, the width of the tower is getting lesser. Okay, every time the width of the tower is getting lesser. Or you can say if you are moving from the forward direction, the width of the tower is getting higher. Okay, so we are getting the pattern like staircase. Okay, so we will try to design the pattern which looks like Burj Khalifa. Okay, so we will develop a Python code for that, and we will use the concept of binary numbers. Okay, so with the help of binary numbers we will develop the pattern. Okay, so if the binary number is of higher bit, okay, then it will come in the downward direction. If the binary number is of lower bit, the number of bits are less, okay, for example it is 1 or 2 or 3, then it will come in the upward direction. Okay, so as we are moving in the higher number, okay, the number will become larger, and obviously the binary number will also become larger. Okay, so in the starting it will be of 0, 1 digit, 1 bit, 2 bit, then 3 bit, then we will be moved to 4 bit, 5 bit, 6 bit, 7 bit, 8 bit, and so on. So we can, if we increase the number, if we increase the decimal number, obviously the binary number, the number of bits will also increase. Okay, so we will try to develop this code. Okay, and with this we will get a Burj Khalifa tower. Okay, so let us do the coding of it. Okay, so first we will ask what should be the height of the tower. Okay, so we can provide any number, we can ask the number from the user. So I am asking the number from the user. So n equals to int input. Okay, so I am asking the number, enter the height, enter the height. Okay, so height is nothing, it's just a number. It is simply the number of rows. You can say height means what? The number of rows that you want to print. So what should be the height of the tower? You can do anything. Okay, so indirectly we can say it is the number of rows. Okay, so it will print the pattern, okay, in different rows. So it is actually the number of rows that you want to print. Okay, after that I will use a loop. Okay, binary number always start from 0. So again I will start from 0. So range, or I can range 0, and up to a number, okay, up to a row number. So whatever the number that you want to provide, you can provide. Okay, I have already asked the height, so I can go up to n minus 1 or n. Okay, it is up to you. So n minus 1, n plus 1, n plus 2, whatever you want. Okay, so here I am giving 0 to n plus 1, 0 to n plus 1. So obviously it will contain n plus 1 elements, n plus 1 rows, n plus 1 rows. Okay, so for example, if I am giving here 15 rows, okay, if I am giving here 15 height, then obviously it will go up to 0 to 15 plus 1, that is 16, and because the upper bound is excluded, so it will go 0 to a maximum 15. Okay, so 0 to 15. Okay, so there are total 16 rows. Okay, and whatever the number we are getting, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so these are the numbers and these are the decimal numbers. Okay, so what we do, as the number is increasing, obviously the binary number will also increase and the number of bits will also increase. Okay, so these are the numbers, these are the decimal numbers. So we will try to find out the binary number of these numbers 0 to 15. Okay, or 0 to n plus 1 numbers. Okay, or you can say 0 to n numbers. Okay, So we are getting decimal numbers, we will try to find out the binary numbers of it. Okay, so how we can find out the binary numbers? Here I will design one code. Okay, I will write a function for that. Okay, we will write a user defined function, okay, which will convert the decimal number into binary number. Okay, so for example, I am getting the number with the help of function binary, or you can write anything. It is my function. It is my function. Okay, so what you can write? You can write my binary, or simply you can write binary. Whatever the name of the function you want to provide, you can provide it. Okay, so binary is not a predefined function. It is not a predefined function. Okay, this is a function that I will define. Okay, so for what decimal number I will provide from here. So I contains what? I contains the decimal number. Okay, so obviously it will contain 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to a maximum of n. Okay, so for every decimal number it will convert into binary number, and that binary number I want to get in the form of string. Okay, so here I am writing a variable name, okay, which actually contains what? String. Okay, and what that string is? This is a simply collection of bits. Okay, so result I will get in the form of string, and actually it is the collection of bits. Okay, so for example, if you are having a decimal number 8, okay, if you are having a decimal number 8, then what we should get? It should be 1000. Okay, if the number is 9, then what should we get? 1001. If the number is 15, then what should we get? 1111. Okay, so corresponding to the decimal number, we should get what? Its binary number. Okay, so binary is a function, that is a user defined function that is responsible for converting the number, okay, decimal number into binary number. Okay, after getting the binary number, is we will use that binary number for future purpose, and before that I am trying to write the definition of binary function. Okay, so before calling it I have to define it. So I am defining this binary function. So I am taking the number, okay, you can take any number. Here for example I am writing a, okay, or you can write anything. So a is the parameter, okay, which contains actually, a contains what? I am writing here, a contains decimal number. Okay, it contains decimal number, and my objective is to design to convert that decimal number into binary number. Okay, so what strategy we will follow? So let us see with the help of example. Okay, so we use the normal way how we can convert decimal number into a binary number. Okay, so simple, we will follow the same procedure. Okay, so if you see, for example, I want to find out the decimal number of, I want to find out the binary number of the decimal number 8, then we should divide that number by 2 and note down the quotient and note down the remainder also. Okay, so 2 4s are 8, remainder is 0. Again 2 2s are 4, quotient is 2 and remainder is again 0. Again divide the number by 2, 2 1s are 2, remainder is again 0. And in the last time, okay, 2 0 times, okay, and remainder will be 1. And after that we will write the bits in reverse order. Okay, so these are the bits, okay, and these are treated as what? These are actually the numbers, but I will convert into what? Into string. Okay, so that I will get 1 0 0 0 in string format. So this is the binary equivalent of 8. This is the binary equivalent of 8. Okay, so design this code. So let us see this. Okay, you can see this code. So this number, so when I am stopping it, when this number, this is what? This is A. This is actually what? This is A. This is the number whose binary equivalent I have to find. Okay, so this is actually A, and this is what? This is the remainder. Okay, so what you can say, this is A percentile 2. This is A percentile 2. Okay, and what it is A quotient. This is quotient. So how we will get the quotient? I can use the floor division. So this is A slash 2. Okay, so it will give you the quotient and a percentile will give you the remainder, and this is the actual number. Okay, so I have to work on the actual number. Okay, so when I will stop it, in the starting it is 4, then it is in the starting it is 8, then it is 4, then it is 2, then it is 1, and finally it is 0. And whenever it becomes 0, I have to stop it. So whenever the value of a is 0, I am writing the condition if a equal to 0. Okay, so if it is so, then just stop it here. So this is the base condition. So what I can write, because I have to return the string value, so I am writing here empty string, empty string. So if n is 0, if a is 0, not n, if a is 0, if the number is 0, okay, then stop it here. Okay, and it will return empty. Otherwise, return what? Otherwise, return is what you want to return. So for example, in the starting, what I want to return, I want to return is this number. Okay, whatever the remainder in the starting, whatever the remainder we are getting is, in the first time we are getting this 0. Okay, so in the starting we are getting 0, just convert that 0 into string, and in the next time we are getting this 0, so again convert into string. In the next time again we are getting this 0, so again concatenate it with the previous string, and finally we will get this 1. Okay, so again we will concatenate with this 1. Okay, and now the number is 0, so it will not again recursively call it. Okay, so we will get what? 0001, and this is in the form of string 0001. Okay, so after getting 0001, we will finally convert into reverse string. Okay, simply we can convert into reverse string. Okay, so in the starting we should get what? This 0001. Okay, so what I will do, simply come to the code part. So this 0, so from where this 0 will come? Yes, from where this 0 will come. So obviously this 0 is coming from with percentile sign, with modulus, with remainder. Okay, so you are dividing the number simply and you are taking out the remainder. So we can take the remainder with the help of modulus operator, and this 0 we will get it here, but we will convert that into string so that it will be concatenated further. Okay, so this 0 we have got. Okay, this 0 we have already got. Now we have to recursively call, okay, for the number which I have got here. Okay, it means what? This is what? This is a divided by 2. A divided by 2. Okay, this was the modulus operator and this is the floor division. Okay, so we have to recursively call for the lesser number. So I am just concatenating with the binary function again, but with the quotient part. So how we will get the quotient? It is a divided by 2. We want to take only the integer part. Okay, so again it will do recursive call. Okay, so this is simply the definition of binary function. Okay, let us see the example. For example, I want to convert this 8 into binary. So if you compare this a is equals to 8, 8 is not equals to 0, so it will come here. So it is what? It is string. 8 percentile 2 is 0, so it becomes what? String 0, so it is what? String 0 plus binary of a divided by 2. So 8 divided by 2, that becomes 4. Okay, so again it will do the recursion. Okay, so it will be equal to what? 0, previous 0 plus binary 4. So now this time a is 4, a is not equal to 0, so it will go here. 4 percentile 2, 4 percentile 2 is again 0, so it will be a string 0. Then it will recursively call what? Binary 4 divided by 2, that becomes what? Binary 2. Okay, so again we do the same procedure. So 0 plus 0 will be concatenated, so it becomes 0 0. Okay, it will be 0 0. Then binary 2, so a equals to 2, so a equal to 2, a is not equal to 0. Okay, so it will come here, and string 2 percentile 2, 2 percentile 2 is again 0. Okay, plus what? Binary 2 divided by 2. So 2 divided by 2 is what? 1, binary 1. Okay, then it becomes what? 000 in the string, because 00 is concatenated with the 0. Okay, so it becomes 3 times 0 and then binary 1. So a equals to 1 this time. So a equals to 1, it is again not equal to 0. So it will come here. So 1 percentile 2. So 1 percentile 2 is 1. 1 percentile is 1. Convert that one into string. So it will be 1 like this one. And plus binary 1 divided by 2. Now this time it is 0. Okay. So again it will go into the definition part. So a equal, now this time it is 0. Okay, so it will return what? Empty. Okay, so here I will get what? 0 0 0 and 1 will be concatenated. Okay, so it will be 0001 and binary 0, it is what? Empty string. So finally it will be 0001. Okay, finally it will be 0001. Okay, so it will return 0001. It will return 0001 in the forward direction. So we are getting the result in this way. Okay, from top to bottom, but for getting the binary number we have to write in the reverse order. Okay, so if we are getting the numbers in from top to bottom, so there is nothing to do, simply we can reverse the string. Okay, if we are simply reverse the string, then we will get the binary number. Okay, so here I will get the collection of bits, okay, but in reverse order. Okay, but in reverse order. So the next responsibility is I have to reverse it. So how I can reverse the string? Okay, so there is a simple way. There is a concept of slicing. So we can write s1 colon minus 1. Okay, so what it does, it simply reverse the string. Okay, so this 0001, whatever we were getting in the earlier case, so 0001 is now converted into what? 1000. Okay, and this was in the form of a string. Again, it is in the form of a string. So 0001 will be converted into 1000. Okay. So this is the definition of binary function. We have defined our own function. Now binary, it is converted into binary. Okay. The next thing is we have to print these numbers. Okay. But we want to print these numbers because I have to print the Burj Khalifa in this manner. Okay, so it should be what? It should be right justified. It should be right justified. Okay, so for right justified, we have to find what should be the maximum width. Okay, so what should be the maximum width? Whatever the highest height, or whatever the height, or whatever the maximum number of rows. Okay, so whatever the rows you have provided, just convert that number into binary and find out the number of bits. Whatever the number of bits in the last number, that will be the width of the tower. Okay, so I can find out this. So here I have found the number of rows. So here I can find what? Binary of, okay, but we have provided the definition here, so we have to provide the definition in the starting. Okay, so here I can provide the definition because I have to call this binary function. So I have called this function. For example, I have given 15, so it will convert that 15 into 4 times 1. Okay, so it will convert that 4 times 1. Okay, so we are getting in the top forward direction. Okay, we are getting the number from top to down. Okay, so it doesn't matter here. Okay, it doesn't matter here because it will give the correct total bit. Or what you can do here, you can again you can write the logic for reversing the number also. Okay, so here we are not writing the number. Here the objective is simply to find the number of bits. Okay, so if you are moving from top to bottom or bottom to up, the bit will be same, the length will be same. So this will provide you the binary number. Okay, and we have to find out the length because it is a string, so it will find out the length. Okay, and again if you want to provide a reverse number, then we can write slicing here also. Okay, but there is no need. So do not write this one. So it will give you the total width. So I can write width equals to length 15. So 15 is obviously, it will provide 1111. Okay, and because it is a string, it will find out the length, so width will be 4. Width will be 4. The length will be 4. Okay. So I will write justified this string. So s1 dot write justified. For this we are having a function rjust, and I can provide the width. Okay, so it will adjust according to the width, and with this we will get a new string. Okay. So till now, okay, we have completed. We have written the function definition, and I can check the result. Okay, I can check the result. So I am just saving the program. Okay, now program is saved. Now you can see the output. Enter the height. So here I am giving 15. So nothing I am get because I have not written any print function. I have not written any print function. Okay, so print s2. Print s2. Okay, so the number of and the height is 15. Now this time we are getting all the binary numbers and it is right justified. Okay, so it is looking like Burj Khalifa, but this is not coming in color, so we can provide the colors also. Okay, we can provide the colors also, so it will look very good. Okay, it will be, the pattern will be interesting. Okay, if we provide the colors. So for the colors, okay, what we can write, we can import a module from CLR print. I can use this module from CLR print import star. Okay, and instead of this print, I can use CLR print and I can write the color. Okay, so CLR equals to, for example, here I am writing red. Okay, so it will display in red color. It will display all the binary numbers in red color. Okay, but this is not our objective. We want what every line or the number, the line, the starting 3 lines should come in different color. The next 3 lines again it will be in the same color. Okay, so for example, I can provide the first line in red color, then green, then blue. Again I can repeat the same color: red, green, blue, red, green, blue, red, green, blue, red, green, blue. Okay. So in the starting 3 lines, I want to provide red, green, blue color, and in the next 3 lines, again I want to provide red, green, blue color. Okay, and similarly in this way, I can print the pattern in different colors. Okay, so that the output should look very interesting. Okay, so for that I can write the different colors, but I have to write in some condition. So I am taking the value I here. So because I am using 3 colors, so it is taking what I is in the first time I is 0, then in the next time it is 1, then it is next time it is 2, then I is 3, then I is 4, then I is 5, and because I want to use only 3 colors, so I can divide the number by 3. Because I want to use only 3 colors. If I want to take 4 colors, then I will divide by 4. Okay. So if I percentile 3 is this, so I in the starting I is 0, so it will be 0. In the next time, if I will divide the number by 0, then it will be 1. Okay. If the number is 1, if it is 2, so 2 percentile 3 is 2, and in the next time I is 3, so 3 percentile 3 is 0. So again it is what? Again it is 0. 4 percentile 3 is 1. So it is repeating. Okay, these numbers are repeating. So 4 percentile is 3. 4 percentile 3 is 1. Okay, not 3. 5 percentile 3 is 2. So these numbers are repeating: 0, 1, 2, 0, 1, 2, 0, 1, 2. Okay, every time it is repeating. Okay, so we can write the condition like this one. Okay, so if I percentile 3 equals 0, then we will print the pattern in red color. Similarly, I can write the colors for is and similarly I can write the last color. Okay, so red, next time I can provide green. Okay, and similarly I can provide blue color. Okay, and here I will write if I percentile 3 equal 0, here I can write I percentile equal 1, and here I can write I percentile 3 equal 2. And after that I for I equals to 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, if the value of n is 15, okay, so obviously the remainder will come in the form of 0, 1, 2, 0, 1, 2, 0, 1, 2. Okay, so in among these conditions, okay, any one of them should be true. So if alif or alif, if alif alif, okay. So now it is written correctly. Now again I can run the program. Okay, now I am running the program in the fresh window. Okay, so if the height is 20, for example, if the height is 20, then it is coming in different colors. Okay, so every floor of the tower is coming in different color. Okay, after the gap of 3, 3, after the gap of 3, 3. Okay, so the top floor is coming in green color, then second last, okay, second top floor, okay, from the last it is coming in blue color, then it is red color, then again it is repeating green, blue, red, green, blue, red, green, blue, red. Okay, so it is looking like what, yes, whatever the image I have shown earlier. Okay, so it is look like this one. Okay, so if we are moving from downward direction, okay, so the width of the tower is getting narrower. Okay, so here also the width of the tower is getting lower if we are moving from downward direction. Okay, and because we are using idle, okay, so the background is white. If you see the same image on the command prompt, then the output look very good. Okay, on the black background, it will look very interesting. Okay, so here also I am trying to run this program on the command prompt also. Okay, so cd desktop, and the program name was whatever my program, it is 4 times s then pi. So Python 4 times pi s dot pi. Okay, enter the height, yes, whatever the height I want to provide, yes, now it is looking very fine. Okay, because the background this time it is black. Okay, so this is the pattern. You can see the output in the white background, okay, as well as the black background. Okay, so this picture is looking like Burj Khalifa. Okay, so thank you all. I think you have enjoyed this video. Okay, so you can develop this code, you can see this code, okay, and you can try to develop by your own. Okay.